Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. By saying shortcuts, I mean the tips and tricks through which you can save time in the competitive exams, especially in the numerical ability or the quantitative aptitude portion. They all are based on very basic concepts. Concepts which you have studied only up to class 10th or so, and you need to know some smart things and some smart tips and tricks through which you can get rid of those traditional methods and save time by skipping steps. And that's what I'm going to do in this video also, to make you smart. This is the topic where we need to have a short trick for converting what? The non-terminating recurring decimals like 7.3333 and it goes on and on. So this actually can be represented as 7.3 bar because the 3 is repeating, and it is to be converted to a fraction form, that means rational form. As we all know that non-terminating recurring decimals are actually rational, so they can be represented in the form of P upon Q. So if I want to write 7.3 bar in the form of P by Q, what should this result be? So you know the traditional approach, right? So I'm going to demonstrate the traditional approach first and show you what exactly works the best, when it comes to class 8th, class 9th exams. But at competitive level, what you need to do will come after that. So first the traditional approach and then the short trick, and you yourself compare and tell me in the comments, did that save like 10x time for you? I think yes. If you are able to solve a particular question in 3 minutes, you will do that in around 10 seconds. Yes, I mean it, 10 seconds, and your answer will never be wrong. So let's see the full video and let's understand the traditional approach for doing this question first. So for simplicity's sake, I am taking a question where I have to convert 1.4125 with a bar over 125 in the form of P upon Q. Now what I am doing here on this slide is to take up the traditional approach. Okay. So normally when students have to express a non-terminating recurring decimal in the form of P upon Q or in the form of a rational number, then they assume the question to be X, and then they just check how many digits after decimal do not contain a bar. That means they are not repeating itself. So 4 is not repeating, right? Only 1 to 5, 1 to 5, 1 to 5 is repeating. So the first thing is to multiply this by 10 so that this digit 4 comes on the left side of the decimal. So this becomes 10x, and on the right hand side this becomes 14 point, and 125 bar remains as such on the right hand side. Now the next step is to see how many digits have a bar over them. So here we can see 1, 2, 3. 3 digits contain the bar over them, and therefore we need to again multiply this by 1000. So 10x becomes 10x into 1000, that is 10,000x, and on the right hand side if you multiply 14.125 bar by 1000, you are going to get 14. 3 digits move towards the left of the decimal, and after that 125, 125, 125 will keep on repeating. So 125 bar will come as it is, and here this 10,000x is on the left hand side. Now after doing this, you need to be aware that we have to subtract this equation and this equation. So 10,000x, see the number of steps, 10,000x minus 10x on the left hand side here, and on the right hand side this number minus this number. So 14125.125 bar, and subtract what? 14.125, I'll write it here, 14.125 bar from this. When you subtract this, this will become 9990x, and on the right hand side, since the number after the decimal is same, so the decimal is going to vanish. So it's all about subtracting 1, 4, 1, 2, 5 and 14, which becomes 1, 4, 1, 1, 1. Right? And now the value of x comes out to be 1, 4, 1, 1, 1 upon 9, 9, 9, 0. Now this actually can be the final answer if there is no common factor between numerator and denominator. So I can see this divisible by 3, but here 1 plus 4, 5, 6, 7, 8. So this is not divisible by 3, and therefore your answer for the question, what was the question? 1.4125 bar is actually 14111 upon 9990. Now this is the way you do it traditionally. Now look at the number of steps, friends, and look at the amount of time I have taken to explain that. And now comes the surprise for the video. How do you do it in 10 seconds? I am going to take so many examples, okay? So watch. Before that, when I talk about short tricks, we have a huge collection of short tricks. Where are they? They are present in this short tricks for quantitative aptitude ebook. And this is especially for all the school students who are looking for, developing that 10 times faster speed of calculation, or those who are preparing for all sorts of placement exams mentioned here, right? They are all competitive exams having quantitative aptitude as the portion. This contains 24 chapters. Normally, all those chapters cover whatever is asked in quantitative aptitude. Over 300 short tricks. 300 short tricks. 10x faster calculations, obviously. And then the surprise element is the reasoning course. Because if you purchase this ebook of short tricks, the reasoning course also comes with a combo of short tricks. Right? So if you want to have this surprise element and a big important thing in your kitty which will help you throughout your life, just send me a message on WhatsApp 9896369963 and I'll tell you the cost of this combo is going to surprise you. Okay? So go for it, friends. This is especially for you and your mathematical abilities. Okay, friends? Let's see the first type of question now. This is type 1. See why I wrote type 1 here? When all digits after decimal repeat. That means after decimal there is no digit which is not repeating. It's like 17 point maybe 27272727. So 27, 17 point, then everything is repeating 27272727. Okay, this is type 1 type of question. So let's take some examples. Suppose I have a question where it is 0 point and 6 is repeating itself. So 0.6 bar. Now I told you all the digits after decimal are repeating. So 6 is the only digit after decimal and it is repeating 6, 6, 6, 6, 6. So what do you do in such case? Just forget the bar. Okay? We have to first forget the bar. So if you forget the bar, this is going to become what? 0, 6. That means 6 only. And divided by, if there is only one digit which is repeating, divided by 9. Okay? If there are 2 digits repeating, divide by 99. 3 digits repeating, 999. And so on. Now this is the first thing we must know. Rather, if you think about it like this, say suppose here we have 6 under the bar, minus before decimal you have a 0 and then write a 9, it will be more appropriate because this is the rule I am going to apply in the next question. So 6 upon 9 and that gives me what? 2 upon 3 as the answer for this particular question. Likewise, suppose I have 5.3 bar. Now 3 is repeating. Now when I have a number before the decimal also, then what do? Forget the decimal, okay? And forget the bar. So you get 53 minus the number before the decimal is 5 and how many digits are repeating? Only 1. So divided by 9. There you go. You get 48 upon 9 as the fraction equivalent or the rational number equivalent of 5.3 bar. You want me to take some more questions? Let's vary the question now. 4.54 bar. Now here 2 digits are repeating. Okay. Let's apply the rule again. So forget the decimal and forget the bar. You get 454 minus what? The number before the decimal 4 and divided by what? The number of digits repeating is 2, right? So 2 nines in the denominator, and that gives you 454 minus 4, which is 450 upon 99. That reduces to, if you divide it by 3, 150 upon 33, and that further divisible by 3, so 50 upon 11. Now you can check. Divide 50 by 11 and check, did you get 4.545454 as the answer? You will be really surprised, friends. Okay, one more. 178.19 bar. Right? Now watch. 17819, or the complete number, minus the number before decimal is 178. So I'll subtract 178 and divide by what? Two digits repeating means 99. So 17819 minus 178 happens to be 17641 and divided by 99, and I don't think there is any common factor here which I can cancel, and therefore this itself is the fraction equivalent of 178.19 bar. One more question and then we will move on to type 2. Let's take a big one. 2.267 and all three digits are repeating. 2.267, 267 and so on. So what do you do here? 2267 minus the number before decimal is 2 and divide by what? Yes, you guessed it right. It is 3 digits, so 3 nines. And now 2265 in the numerator and divided by 999. And can you see there are some common factors here? I think there is a common factor 3 here. So 3, if you divide this by 3, 3 sevens are 21, 3 fives are 15, and 15 means 3 fives are 15. And in the denominator 3, 3, 3. And now this is not divisible by 3, right? And so this is the rational equivalent of 2.267, 267, 267 and so on. Right? Okay. If you have understood this, now this is half job done. Let's have the second type of questions where we have some digits which do not repeat. That means after decimal there are some digits which are not repeating. Okay. Let's take some examples. 1. Let's have 0.16 and only 6 is repeating. Now see, there is something which is not repeating. So what do you do here? In this case, forget the decimal, forget the bar. So you get 16. And then what do you have to subtract from this? That is important. Now forget this part which is having a bar. What is the other number? It is 0, 1. And so I have to subtract 1 from this and divide by what? That is also really important here. How many digits are there after decimal? You have 2 digits, so 100 minus how many digits have a bar? 1 digit, so 10. 2 digits means 100 and 1 digit having a bar means 10. Now this will take some time to sink in, and I'm sure little practice will get you through. Okay, so this is what? 15 over 90, right? And 15 over 90 happens to be 15 6 are 90, right? So 1 over 6. And now you can check 1 divided by 6 is that 0.16666 and so on. And you're going to... Let's take another question. So this is 10 point, and after decimal we have 273, and out of that 3 is repeating. Now watch carefully. The number without decimal and without bar is 10273. Subtract what? Only this number which does not contain the bar. So 1027 to be subtracted. In the denominator, out of all the digits, you have to count all the digits on the right hand side irrespective of whether it contains the bar or not. 1, 2, 3 digits after decimal. 3 digits means 1000. And how many do not contain bar? 2 digits, right? So subtract 100. Now this is where you will feel more comfortable, right? So subtract this, you get 9246 and divide by what? 1000 minus 100 is 900 Now you can reduce it to simplest form, divisible by 2. So 4, 6, 2, 3 divided by 450. Is it divisible by 3? Yes, it is. I think yes. So this will give me 1, 5, 4, 1, and in the denominator 150. And still no, I think it is not divisible by 3 now. And this happens to be the correct answer for the question. Now likewise, you remember I took one question here in the beginning of the video where I told you the traditional method, that was 1.4125 bar, right? And we found out the answer to be, I think, 1411 upon 9990. I think that was the answer. Okay, so let's do it directly now. The entire number is 14125 minus what? The number without bar, that is 14, and divide by what? How many digits are there after decimal? 1, 2, 3, 4. So 4 means 4 zeros, minus how many digits after decimal don't contain a bar? 1. So 10. Now watch. 125 minus 14 is 14111, and in the denominator 10,000 minus 10 is 9,990, which is the exact answer which we found out in the beginning of the video using the traditional approach where we took 3 minutes. Here you will take only 10 seconds, right? So prove that this actually can be done in 10 seconds. So friends, I'll give you a DIY question. So you have to post your comments and you have to tell me whether you could solve this using this approach or not. Okay, 7.9354 and a bar over 54. So you have to tell me the fraction equivalent of this particular non-terminating recurring decimal, and I'm sure you are going to get it right within 10 seconds. Okay, so friends, if you like this video, do share it with all your friends so that they can take advantage of these minor things which can save so much of time in the competitive exams and come out successfully in the first attempt itself. Fine. So all the best for the question which I have shared with you. If you have not subscribed the channel till now, please do it, and do not forget to click the bell shaped icon for getting all the notifications of all future uploads. Thanks for watching this, friends, and all the best for your practice.